Okay, so welcome back to in today's session. What we're going to see is introduction to the TCAD lab. We're going to have an hands-on experience. Thanks to the chip-in program, we have the Synopsys Centaurus license with us. This is one of the costlier software, but thanks to the government for providing to us. Right. So make use of this opportunity. So the idea was I will show you how to open right? The workbench, how to add the process tool or how to run an existing example, see the output and see the input to the tool. Okay, that's the idea. That's what we're going to do. Okay, so for that, first let us open mobile extern. So just type Windows, type mobile extern, right? I'm pretty confident the similar arrangement will be there with you guys. Okay, so if you open the mobile extern, so you have to go to the session. Mostly they will be added here already. But if you are doing for the first time session, SSH, then you will be given your host ID and username. Enter them and just give OK. I'm canceling now, but you have to give your host ID, so IP address and username and give OK. So we will get the user will get added here. Okay. So let me show you. So once you do that, you will get a login like this. And it will be asking for your password. Enter your password given by you by the lab technician. Okay, now what you have to do is you have to now we are going to invoke the software. This is just a interface between the server and with us, right? So we're going to invoke the software running there. It's going to be Sentaurus TCAD. To invoke it, use command call SWB Sentaurus Workbench and give enter. So since I'm accessing it in uh, remote basis, it will take some time for me. So already I opened that one. So once you enter SWB, you will get this window opening. Okay. So when you do for the first time, you have to give this path correctly. Okay. So this is your working directory. It means the files, whatever you create, it gets saved here. This is the example files. Okay. So we'll be using on the MC guys. It's not like C programming or something we build from the scratch. Here we take from the examples and we modify them. The more important thing is you should know what the line, you should understand what the line communicates, and you should know how to modify. You should know how to tweak it. That's what you're going to do here. Okay, and more importantly, we'll be seeing at the results. Okay, so because that's what you're going to learn in this course, and you'll be correlating with the simulation using the Centaurus TCAD. Okay. Okay, so hope you're able to open this window. Now, let me show you. Let me give you some, so I told you this is a working directory. This is an example files. This entire thing is called tree. Each row is called branch and each cell is called node. Okay, tree, branch, node. Okay, now let me show you how to create a new folder for yourself. So you click on this one, right click, folder, new folder, and give a name for that folder. Okay, so let me repeat, right click, folder, new folder. So let me call it as Centaurus process. We're going to do now. So let me call it as SP, or I suggest you create with your register number. Okay, so here I'm creating with Centaurus process simulation, so SP sim, but you create based on a register number. That is always good. Okay, so now you have created this. And now I'm going to copy. As I told you, we are not going to create from scratch. Maybe I'll show you how to do that as well. But generally, it's easier to take from the examples. Okay. So for to take from the examples, go to getting started, because here you can find basic examples. Go to SWB. This SWB is called Centaurus Workbench, where you link different tools. I'll show you in a short time. And select this file called simple mass. Right click, copy, Go to your folder you have just created, right click, paste. Now see, you can't run in the example directory. Okay, that's just locked. You can't run that. You have to copy to the working directory to run anything. Now double click, and you got your tree opening here. And you can see multiple tools here. This is your S process tool. I told you, no, process TCAT. I mean this tool. So this tool will help us to run the process models. Okay, to do process simulations. Okay, this tool will run us and help us to do device simulations. S device. S stands for Centaurus. Centaurus process, Centaurus device, Centaurus visual. Visual is for to look at your outputs. Okay, so that's why we use this visual. Okay, now it's a MOSFET. Okay, so let us run the simulation and see the output first before we go to the input. Okay, so how to see is just select the entire branch and give run and give OK here. Okay, so once you just check if there are any syntax, it shows some error here. Otherwise, just close and go here, double click. You can see the log where you see a lot of informations. You see, it is checking for the syntax. Just 2 to 3 minutes, it will give you some more informations. It will show you after checking the syntax, it starts solving the equations. Because remember, right, it will be differential equations. So meanwhile, it ran. Let me open the manual for you. So see, it's done the syntax check. That is complete. You have to look into the log, so you will learn more details from the log. Okay. Okay. So let me show you where the manual is. Okay, to link it with here. Okay. So to see the manual, go to help manuals. So you also have training. So you can also explore this. So you have a training for each tool, S process, S device. So I strongly recommend you to go through them as well. Okay. So right now I'll show you manuals. Okay. Okay. Sorry, something else is opening. I'm closing this right now. Here. So this is what your manual. So I'm going to open the Sentaurus process manual. Okay, which you are going to use. So there's another way to create the device, which is called Centaurus structure editor. That you just create the final device. But Centaurus process is more more similar to the way you fabricate devices. Because Centaurus structure editor is just you create the final geometry. That's all. You don't know how the device has evolved. Okay, how actually the device was made. Okay, so Centaurus process. So that's what we're going to learn in this course. Double click on this, you will get a manual open. It's a bit slow here. So you can see uh, it is solving these equations. So you can see this is solving the equation each points. You guys remember each mesh points. It's a log. Yeah, it's opening here. It's taking some time. Okay, so I thought of showing. So okay, won't let it come. Otherwise, I will come back to this manual bit later because it's taking a lot of time. Okay, so it came. Okay, so here you can see this is a manual. Um so let me go to diffusion. Let me show you some equations over there. So you can even see the commands to invoke the diffusion mechanism. Diffusion is, I told you in the last video, right? When you heat, the dopants start entering them, right? So the big driver is the temperature for the diffusion. So the temperature and how long you expose to this temperature, the time duration. These are the key metrics. So uh, let me show you the differential equation as well. That is the heart of this command. Okay, so it comes here. Here it is. See, so maybe we'll go to the direct transport model. So this is a differential equation. See, so we'll be learning in this course about this differential equation as well. Let me show you a very simple differential equation which will be learning in this course. This is called Fick's law. So this differential equation will be solved at every points, every mesh points. That also will I will show you. And the result is the dopant concentration. Okay, the profile. That's what you will be getting as output. Okay, so this is a model. Okay, which is getting solved using the TCAD. So this is a model, the process model. You'll be learning it, which will be solved by the tool. This is called process TCAD. S process. So S process engine help us to understand this equation better. So we are learning it using this tool. Okay, fine. We'll come to it. So don't worry about it. We'll be learning it in the coming lectures. Right now, I just want to show you this solving a differential equation. That's what it is called. What? It is called numerical simulations. Okay. It's not a compact model. Okay. So it will run for some time. So what I did is already I ran some simulations, same simulation. I will show you the result. Okay. So after running, so if it is running, it will be blue. You can see here running is blue. If it is yellow, it's done. Okay. So to see, let us see the output first. So let me remind you what we done. We just opened the SWB. We created a new folder. We copied a file into it, right? And then we ran it. Just selected the entire branch and we ran it. That's what we did. Now we're going to see the output of this process. Don't worry about the S device today. Let us focus on this process. So right click. So to see the output, you have to go to the node. Okay, go to the node, right click on the corresponding node. This corresponding node points to this condition, this fabrication condition. Okay, so right click, visualize, select file. Okay, so yes, visualize, yes, visual will open the output. Okay, so as I told you, is visual. So you will mainly be using these three tools: S process, S device, S visual. Okay, S process to create the device, S device to run the IV characteristics to check the device working, and S visual to see the outputs. Okay, hope it is clear. You got the MOSFET structure. Okay, if you want, you can zoom it up slightly here to see the source, drain, and the channel. Maybe if you want to see the gate oxide, you want to zoom it even further. This is a gate oxide, right? So this is a gate oxide and your gate contact. The pink line you see, that's a contact over it. Okay. Um, Now what you can do, I will show you the profile. See, as I told you, see the dopants. Since the dopants have entered from the top, you can see more dopants in the top, and they are gradually decreasing.